Welcome back to the Enterprise Security class. Today we'll be covering Chapter 3 on Infrastructure and Connectivity. This chapter focuses mostly on hardware, which makes sense when you consider the term infrastructure. The infrastructure of a network are all of the components that put it together. It's the backbone of your environment, and it's going to consist of all of the physical devices that hook everything together. You start at the workstation with a network card, you've got cabling or you've got wireless connectivity. That goes to a wireless access point or to a switch. Those switches are often cascaded. You've got servers in there, you've got firewalls, you've got routers. So when you look at the term infrastructure, you're looking at all of those components. Of course, software is part of this as well. You will be using drivers on any of these devices. You'll be working with firmware, which you can consider in a category of software. And then there are different pieces of software that you will be using, and the book discusses that, specifically talking about protocols. In the section entitled Working with Hardware Components, there's a real-world scenario that describes putting together an infrastructure list. This box correctly states that most people don't have this in place. One of the things that I do in my business is make sure that I do have this information in place. I keep track of models, I keep track of purchase dates, I do keep track of firmware because that needs to be updated on a regular basis. There's a lot of good reasons for this. One of the more important things is keeping track of how old your equipment is. If you're planning well, what you'll want to do is have a routine set up where every 5 years you roll out old equipment and purchase new equipment. If you have an accurate list of all the different devices that you have, you can budget better. Management always likes that when there are expected purchases rather than unexpected purchases. In the section entitled Working with Software Components, there's a good discussion on the term Network Operations Center, or NOC. Small businesses will not have anything like this, but larger businesses that have an extensive telecommunications network are going to have a network operations center. They've got people monitoring devices, monitoring connectivity, looking for denial of service attacks or any kind of an outage so that they can keep the business up and running. The section Understanding the Different Network Infrastructure Devices is going to cover all sorts of different hardware components. And the first thing that we're going to look at are firewalls. In its very simplest definition, a firewall is used to separate different parts of a network. Most of the time you'll see a firewall separating the internet from a private network, but you can have firewalls within an internal network, especially if you've got really secure communications or there's some compelling reason that you need to segment your network. There are three main tasks that a firewall can do. And depending on what you purchase, it can do one, two, or all three of these functions. The first thing that a firewall can do is function as a packet filter. And this is really your first line of defense against intruders. When you're using a packet filter firewall, it's not really looking at any data. What it's looking at is what port is this traffic destined for. Every TCP/IP packet will have an associated port with it. If it's HTTP traffic, it's going to come in on port 80. If it's SMTP traffic, it's going to come in on port 25. By default, most firewalls will have everything turned off, and you need to turn on specifically the ports that you need in your environment. Sometimes it's kind of hard for people who aren't real up on communications to configure the firewalls, but there are wizards that can often take you through these. If you look at the table in the real-world scenario about deciding which traffic to allow through, this can be kind of overwhelming for someone who is new to network administration. Generally, you're going to be using port 25 if you have an internal mail server. If you don't have an internal mail server, then you'll probably be using POP3. You might be using port 25 if you're doing outbound email. Port 80 is used for web traffic, and you'll use that for access if you are hosting an internal website. Most firewalls will allow outbound traffic to any port, and they'll recognize what device generated that request so that when the traffic comes back, it matches up with an outgoing request. And so that kind of traffic that's internally initiated will be allowed to pass through. Uninitiated traffic from the outside is going to be blocked. One thing that I thought I would point out here is port 25 traffic. If you happen to be connected to the U of M network, you will not be able to send outbound on port 25. And they've got that blocked off so that I suppose only the internal mail servers can send outbound on that. That's actually a really good practice because very many viruses are going to generate email and generate spam. Once these get on a workstation, you can have all sorts of different devices sending out traffic on port 25, and it can be kind of hard to figure out who's sending it. Well, if you configure a rule that says only port 25 traffic from this device, and this device is allowed, then it doesn't matter what these viruses try to do. They'll send packets, but they won't get past the firewall. The next type of firewall is called a proxy firewall, and this is going to be a device that has two network cards in it. The book discusses the term dual-homed, H-O-M-E-D, and the term that I generally use is multi-homed. When you've got a device with either two IP addresses, multiple IP addresses, or multiple network cards, you can call it a multi-homed device. Proxy firewalls are smarter than packet filter firewalls. What a proxy firewall can do is actually interrogate the packets at the application level and permit or deny certain activities based on that application. The book discusses the difference between a GET operation, which is a read, and a put operation, which is a write. And you can configure your firewalls so that only certain workstations can do a read and a smaller number can do a write. You're still allowing traffic for that application on a particular port, and that's the same thing that a filter does. But what the proxy does is look further than that and look specifically at the type of command that this application wants to run. The last type of firewall discussed in the book is called a stateful inspection firewall. What this does is keeps track of connections between different devices. Normally when you're sending packets back and forth, as soon as the packet has been examined and sent, there's no record of it. With the stateful inspection, you can keep track of that. The device can generate reports and generate history for you. As the book discusses, you'll see that these stateful inspection firewalls are subject to denial of service attacks because they've got buffers where they maintain all this information. It's not too difficult to flood those so that the entire buffer is taken up and then it can't service requests. Hubs are the next device discussed in the book, and these are simply repeater devices. Generally, they have very low intelligence. They're also pretty cheap. And what they do is they will just receive a signal, repeat it to all ports on the device. A modem is a combination of a modulator and a demodulator. That's where the name comes from. It used to be that modems would take analog signals for phone services and translate those into digital signals. These days, with digital phone lines, you can also have digital modems. You don't see a whole lot of modem use today. It is still a very good security measure, especially if you're requiring inbound dial-in access. I've seen that most of the laptops now that I'm ordering for clients, modems are optional and they're not a standard configuration item anymore. Speaking of remote access services, there's a diagram in the book that explains exactly what I was talking about. You've got a laptop with either a built-in or an external modem, connects over a phone line, and POTS is plain old telephone service. It connects with the modem on the other end, and then that comes into a workstation or a server that's running security software. It's kind of hard to imagine, but modems are a pretty good way to keep your network secure. If you turn the modems off, then there's no way that anybody can connect in through that method. You can also have software that recognizes the incoming phone number of whoever's dialing, disconnects, dials that number back. Of course, we've all seen movies where some computer genius can override that stuff, but it is a relatively secure way of maintaining security. The next hardware device that the book covers are routers, and I think most of you who are at the COT have probably completed a couple of years worth of router information, so I'm not going to go into much detail there. I will just point out that routers separate different networks, and they can also separate different communication protocols. And the book discusses the fact that if you've got a 10 base T or 100 base T network and you're connecting to a T1 or a T3, those are different communication protocols. Routers with additional equipment can take care of those framing differences. There's a lot of overlap with hardware devices, and you can buy a router that does packet filtering, and a lot of people will just buy one device to take care of that. My suggestion is not to do this. Go ahead and get a router, have it do its routing, go ahead and program it so that it will do as much as you can in terms of security, but make sure that you've got a second device that is actually functioning as a firewall. The book discusses the concept of layering your security, and I think that's an excellent thing to do. You can get a router, a cheap router for a small office for $100 or so. You can get a sonic wall, which I tend to get for small businesses, for $700 to $1,000. I think it's a good idea to have both of those devices in place. The next thing that they've got listed are switches, and switches are a step up from a hub. They're still connectivity devices, but a switch is smarter. Instead of repeating traffic to every port on the device, it will establish essentially a private circuit to whatever the destination is. That cuts down on overall network traffic. Telecom and PBX systems are something that I think you need to worry about. In a lot of cases, people are going to be using voice over IP, so they can potentially share data and voice on the same circuit. That leaves your phone system open to attack from the internet. So patching your voice over IP systems is something that you actually need to pay attention to. It used to be that your telecom people were responsible for that, and you never paid attention to service packs or firmware updates or any of that. These days, I think it pays to work more closely with your telecom vendor to make sure that you are protected and that you've got safeguards in place. I have a couple of clients who are using voice over IP. One is using a combined circuit for voice and data, and then another one actually has separate circuits, one for voice and one for data. That separation is easier to maintain security. It's also more expensive, but that's something to keep in mind. Virtual private networks are more commonly used today than they were in the past. And the diagram in figure 3.9 shows a client connected to some sort of a local internet connection, going out through the internet and connecting to a device somewhere else. It shows that this is a VPN channel appearing to be dedicated. What you do with a virtual private network is you use encryption or a tunneling protocol, and there are many options that you can do with this, but the point is you're trying to make the data that goes between the two endpoints secure so that people on the public wires can't intercept that and then get access to sensitive data. You can do this with hardware, you can do this with software. There's a number of different things that you can do. If you've got a virtual private network and you've got mobile users, what you will end up doing is configuring a client on each of these workstations so that it will connect back to your router or device, your firewall, whatever you've got running. It'll establish a session there and then encrypt the traffic between the workstation and whatever that security device is. The final device that the book covers are wireless access points. You'll see these more and more in buildings or offices that need to provide access a lot of times to the public. People just walk in with a laptop and then they can get on the internet. Unfortunately, wireless traffic is generally pretty insecure. You're letting anybody onto your network and you don't know what state a lot of these laptops are in, if they've got viruses on them, if they've got any kind of a firewall or what they've got. Very often what you'll see these days is you can buy wireless access points or firewalls that have wireless in them, and you can separate an internal wireless network from an external wireless network, and you can configure that external network to bypass completely any of your internal devices. Essentially what you'll do is set up a guest network and it will go directly to the internet. I'm thinking of sonic walls when I'm discussing this. The sonic wall continues to act as a firewall, and it makes sure that any of those guest transmissions have nothing to do with the private network that you've got. I think in terms of security, an approach like this is essential if you're going to be supporting anybody coming in off the street with wireless access. There's a tip that says, at a bare minimum, the wired equivalent privacy, or WEP, should be used across the wireless network. WEP is incredibly easy to hack. If you happen to look around on the internet, it's not too hard to find out ways to do that. WPA is more secure, and if you've got the option at all of using WPA over WEP, I would go ahead and do that.